My name is Katrien van der Kuilen and I'm a member of the Build Up editorial team.
Welcome to Build Up, the European Commission's portal for energy efficiency and renewable energy in buildings. Directly stemming from the Energy Performance of Buildings Directive, Build Up is the meeting place for everyone involved in making the European building and construction sector more energy efficient. Every month we focus on a topic that is key to making Europe's buildings as energy efficient as possible. Exploring that, you can find the latest content such as expert talks, webinars, case studies and more. From architects and engineers to academics and policy makers, we've got you covered. Build Up brings together thousands of registered members to reap the benefit of Europe's collective intelligence on all aspects of energy efficiency and renewable energy in buildings. The Build Up portal benefits from the expertise of our ambassadors. Drawn from industry and academia, the ambassadors bridge the gap between EU and national level and help shape our editorial content. Want to promote your work? Build Up disseminates your research, projects and events through a variety of channels. Become a member to exchange knowledge with your peers. You can disseminate tools and resources, share good practices, and consult open source publications. Join the discussion on social media and become part of the Build Up community, or subscribe to our newsletter to receive the latest news. However you participate, the Build Up portal is here to inspire, inform and connect. Build Up, the European portal for energy efficiency and renewable energy in buildings. Join the community for opportunities and updates.
Again, it's a pleasure for Build Up to host today's webinar and workshop event entitled CircularB Stakeholder Webinar Series 1, Academia and Research, brought to you by the CircularB and Build Up projects. This webinar is the first of 6 webinars CircularB is organizing with Build Up and which delves into the common circularity framework CircularB is developing, with the aim to support decision-making for all value chain stakeholders and to praise the implementation level of the European Circular Economy Action Plan in buildings. In today's event, the project specialists will present their results and research activities that promote circularity in the built environment. Before we begin, we invite and encourage you, the audience, to send us your questions or comments throughout the session. You can do so by using the GoToWebinar question function. These questions or comments will then be addressed at the end of the webinar. Then we would like to inform you that you will be able to find the recording of this workshop on the Build Up portal and on your YouTube channel in the coming days, together with the presentation slides. Finally, we just launched the Build Up survey to give you, our audience, a voice and make sure that your needs and expectations are satisfied within the offering of our platform. We kindly ask you to please submit your responses by the 31st of May to ensure your voice is heard. Let's take a look at the agenda for today. The agenda for today's webinar is composed of 4 sessions. In the first session, Luis Bragança, professor at the University of Minho, will introduce us to the CircularB action. In the second session, Randa Askar, Research Operation Manager for CircularB Action, will present us with the mission and activities of CircularB Action. The third session, brought to us by Mustafa Shamaran, professor at the Hacettepe University, will focus on the valorization of earthquake waste for the transition to a circular economy in the built environment. And last, Teresa Ross will present us with a new tool for measuring circularity. She's a researcher at the Instituto de Tecnologia Ceramica. At the end, we will then have some time for questions and answers, as mentioned before, which will be moderated by us from Build Up. And now, without further hesitation, we move directly to the first session by Luis. The floor is yours.
Hello, good afternoon to all. I would like to, first thing I would like to say is to thank BuildUp to allow us to present stakeholders webinar series, and this is the first webinar where we will try to present all the achievements that we are having in our cost action CircularB implementation of circular economy in the built environment. So this is a cost action, and I try to change slides. Yes. So maybe the first thing to say is to explain what is a cost. Cost is an intergovernmental program financed by European Commission. The mission is to provide networking opportunities for researchers and innovators in order to strengthen Europe's capacity to address scientific, technological, and societal changes. And COST implements its mission by funding bottom-up, excellence-driven, open, and inclusive networks for peaceful purposes in all areas of science and technology. The aim of our action is to define the methodology to develop a common circularity framework for inclusive application and assessment in new and existing buildings, support decision-making for all value chain stakeholders, and appraise the implementation level of the European Circular Economy Action Plan. We are very pleased because our action was approved. We are grateful to COST for financing our action, and the topic circular economy in built environment is raising very much attention. So I believe this will be very interesting for all the interested. So the COST program has 41 participating cost countries, let's say cost countries. This is the way we refer to the members of the COST program, and our action is having the participation of 40 out of 41. The only country that is out is, or that is not yet in, is Armenia. We have 76 management committee members, and we have almost 394 working group members, and we are still open, so we are receiving applications, and we are pleased to welcome everybody that wants to join us. This is something that we are open to, and we like the collaboration with the people that are interested in developing the knowledge about circular economy. We have several objectives. I will not go through all the objectives. I will say that the research coordination objectives focus on enhancing policy, data collection, practical guidelines, performance indicators, and innovative frameworks to effectively implementing and monitoring the circular economy in construction and business models. And we have also one objective that is different from other research projects, that is the capacity building objectives that aim to develop skills, knowledge, and awareness of circular economy through education, collaboration, and engagement activities, fostering its integration and adoption across various regions and industries. So to achieve all these objectives, we organized ourselves in 4 working groups. As you can see in this slide, working group number 1 is focused on circularity strategies and best practices. Working group number 2 is focused on circular value chain and stakeholder engagement. Working group number 3 is focused on the key performance indicators and its framework. And we disseminate our activities and our achievements through the working group number 4 that is dealing with dissemination and results communication. All these working groups are led by 2 colleagues that dedicate their time to promote and to incentivize the participation. And now I ask my colleague and collaborator, Rand Askar, that is also a leader of the working group number 3, that is the most important working group in our action. All are important, but this is very special to continue and to show us our achievements. Thank you, Rand. Please go on.
Thank you very much, Professor Luis, for this nice introduction and passing the floor to me. So now we're going to move to talk a bit about the motivation behind our ideas in CircularB action. We are all aware of the increased environmental impacts and resource intensity of the construction sector. We've been also able to identify there is a kind of unaligned relationship between sustainability and circularity goals in certain cases, that some circular solutions don't necessarily lead to increased sustainability, and this aspect has been overlooked by some existing work. So other challenges include the information transfer and accessibility challenges for the stakeholders, the complexity of building compositions and processes along the life cycle, and the challenges that stakeholders are facing towards making the most of their roles to increase and promote circularity of the built environment. Also, the urgent need to move from theory to practice. So, therefore, building on these challenges, we have made our objectives to build upon current efforts in CE implementation and monitoring for buildings and address some managerial aspects of the value chain. So our framework and the tool that we are developing are eventually aiming to investigate the implications of design and material choices on the overall circularity levels in buildings, and also simulate and report on circularity levels at the different life cycle stages in new and existing building, and also to assess the trade-offs among the circularity aspects and the sustainability factors, including the environmental, social, and economic dimensions. This figure explains our methodology in CircularB. As our chair said, our network is composed of 4 working groups. So Working Group 1 is responsible for the development of innovative solutions and design strategies for both new and existing buildings, and give inputs to feed in the development of the framework that will be mainly happening in Working Group 3. Working Group 2 is going to be responsible about analyzing the network of stakeholders and develop new ideas for opportunities to invest in circularity and develop business models, and also provide some policy recommendations based on an extensive analysis on the standards and ISOs. They are also aiming to develop a management model for circularity with illustrative case studies also to feed in our framework in Working Group 3. So Working Group 3 is the core of this action and will be responsible for the development of the circularity KPIs and the framework itself. So in this working group, we are aspiring to analyze existing KPIs and develop a dashboard for these KPIs for circularity in a categorized way, and then analyze the inclusiveness of the existing endeavors to come up with new KPIs that are complementary to existing endeavors and that bring all circularity aspects into one inclusive framework. The framework is then to be automated within this working group within a BIM environment to align with Industry 4.0 objectives, and then it will be incorporated in the broader perspective of sustainability by aligning our objectives with one sustainability framework, that is Levels framework, the European Common Framework for Sustainability. Working Group 4 is going to be responsible about the dissemination of our results through publications, events, media, websites, and etc. Our final output is going to be the CircularB framework with 6 dimensions: technical, technological, economic, environmental, social, and legal. So following this methodology, our projected outcomes are listed in this slide. So we'll have the state-of-the-art synthesis. We are currently working on a report analyzing the different types of barriers facing the circularity implementation in buildings. We will be delivering a report on innovative solutions and best practices. We're about to launch actually the e-learning platform on the CircularB website, focusing on best practices. Other topics also include the business models and financial studies, the standards and policies at multiple levels, the management model for circularity supported by case studies, the circularity KPIs dashboard, which will contribute to the development of our ultimate goal of developing or delivering a circularity inclusive framework and tool, which will be later integrated in a broader sustainability perspective and automated within BIM environment. Our achievements up to date actually include a book that we managed to publish at the beginning of this year. It's a roadmap towards circularity in the built environment and includes the proceedings of our first workshop, dealing with different topics about our action themes. And we are currently dealing with the publication of our deliverable tool, that is a systematic state-of-the-art that also follows a systematic approach to circularity in buildings, starting from materials through building system to individual building and ultimately to the urban built environment. We've managed to publish some journal papers on the different topics, and standards and policies reports at international, national, and European levels. Regarding our activities, current activities and progress, our working group 1 is currently working on the challenges and barriers towards CE implementation, and they are running a survey on the different types of barriers. This survey is hosted by the European Commission Joint Research Center. Working Group 3, as I said before, is currently working on the development of the dashboard covering the multiple dimensions that we talked about earlier. And we are also working together with our members to develop collaborative publications on specific topic within each working group. Here we have a list of exemplary list of the topic that we are addressing. You can probably consult later when we upload the presentation. Working Group 2 is actually working on discovering or identifying new business models opportunities. We're also working on the updating our standards report, including more countries, and the e-learning platform. So in the following slides, I'm gonna give you a brief presentation about some sample activities that we are currently working on in CircularB. So the first one is going to be the countries fact sheet that we developed in our policies and standards report. That was a pretty important activity. We held a survey on a national level, policies and regulations, and we gathered responses and references using our network members. So, and we eventually managed to develop a country-specific fact sheet for 21 countries. So the national members from these countries helped us to translate the native documents into English and collect the information that is relevant to circular economy in terms of policy and regulatory frameworks, the standards they are using in their countries, the platforms that are supporting this work, the financing sources, and also some challenges and barriers these countries are facing, along with good practices examples. So our aim within this activity was to develop a reference repository in English that is accessible by all stakeholders in the construction industry to be aware of the status of circular economy implementation in the built environment in these countries and to make like comparisons. Our second activity for today is the e-learning platform that we are about to launch within this year of the action. We are the second year of the action. We are considering a collaboration with the Canmatic project, and the e-learning platform will be hosting online courses, didactic material, will be providing a repository of circular economy important documents. Our stakeholder webinar series will be posted there as well. We are trying to provide a dynamic interface for the users with online learning, test and polls, and also certificates. The third activity that I'm going to present today was held within WG3, and it was about the consideration of circularity implementation within international sustainability schemes. So what we did in this activity is that we analyzed the relationship patterns between circular economy and sustainability, and we highlighted the differences and the borderline between the two concepts to use eventually a circular economy framework for the West hierarchy, the 10 R's principle, let's say, to be analyzed within 5 wide-known sustainability schemes: BREEAM, DGNB, LEED, Level, and SB2. So what we did within this activity is that we created experts groups, each responsible for one of the 5 international sustainability schemes, and each of the experts analyzed each R principle implementation within each credit indicator or criterion of these 5 frameworks. Actually, we got some pretty interesting results, and I would like to invite you all to consult the results in our D2 that will be published very soon regarding this research. So the final activity sample that I'm going to present today is the circular economy key performance indicators dashboard that we are developing in also working group 3. We started working on the dashboard this year, started in November, and we are going to deal with the categorization of different indicators types over dimensions and factors for circularity and sustainability. We're going to consider also process factors, contextual factors, including the political, cultural, local, and regional factors. The indicators also are going to be classified according to their scope, whether they are addressing a whole building level, a system, a specific system level like a structure, or the envelope of a building, or even like whether they are addressing components and materials. We are also considering the classification of the indicators over the different life cycle stages of buildings. And we are using as references different tools and frameworks that are existing in the literature, standards and ISOs, and also circularity implementation patterns within sustainability framework. Regarding the information types that we are going to include in this dashboard, and we already started to incorporate them, that would be the indicators type, the reference tools, the calculation information requirements, the barriers, the limitations and validation methods, case studies, and the sources. And we are creating a template to be followed by each indicator, and would be also supported by illustration like timelines, schemes, and hierarchical trees. So lastly, I'm going to present here the major event during the 4-year CircularB action. So we have 4 main categories of event. The first one is more action-specific events for members, like including the core group meetings, the management committee meetings, the working group and sub-working group meetings. And then we are also organizing training school during our action lifetime. The first one is going to be held in May, next May, in Timișoara, Romania, to test solutions and put hand-on practice. The second one is going to be held next year in Riga, Latvia. The theme is going to be about circular business models and management schemes. And the last training school is going to be in the 4th year of the Action 2026 to test the KPIs and the assessment tool. Regarding our workshops, we managed to organize and held 2 workshops during the first year. The first one was in Skopje. It was about like brainstorming and knowledge sharing among CircularB members. And the second one was in Cordoba to consolidate the systematic state of the art in deliverable 2. And our last workshop is going to be in year 3, 2025, to test the dashboard and present the e-learning platform. Regarding our conferences, we are planning to have 2 conferences, a midterm conference and a final conference to showcase our preliminary and final results respectively. And the midterm conference is going to be held simultaneously with the first training school in Timișoara, Romania, where 48 papers from our members will be presented. So that was a brief presentation about some of our activities in CircularB. Thank you very much for listening. For more information, you can consult our website and this presentation after we make an upload to the website. So now I will pass the floor to our colleague Mustafa Shahraman to present his research.
Thank you, Rand. Hello, everybody. Okay. My name is Mustafa Shahmaran. I'm one of the MC member of CircularB Cost Action. Today I am talking about the transition of earthquake and disaster wastes into the circular economy in built environment. As you all know, Turkey experienced a very serious earthquake disaster in 2023, and the efforts to be carried out within this scope have gained vital importance. And if we look at the construction industry closely, it is one of the largest sectors globally and is constantly growing as a result of the activities such as population growth, urbanization, and immigration. However, the extraction of raw materials for the production of building materials and the intense use of the energy in the sector bring environmental and the health problems at the same time. For example, just during the production of Portland cement, around a ton of the carbon dioxide emissions per ton of the Portland cements are released, plus around 2 tons of the raw materials will be used for the production of each Portland cement. And in addition, a significant amount of construction and the demolition waste is generated as a result of the activities such as maintenance, repair, demolition of the buildings, and their direct discharge to landfills causes great damage to both environment and economy. So the random disposal of these construction and the demolition waste is a major environmental threat, not only for our country, for all around the world. And at the same time, not reusing these waste material is contrary to the concept of the circular economy. These graphs in this table shows the amount of construction and the demolition waste generated worldwide, which has reached, unfortunately, billions of tons. As I said at the beginning of my presentation, on 6 February 2023, 2 earthquakes with the magnitude of 7.7 and 7.6 occurred in Turkey. And the 2 major earthquakes caused damage in an area of approximately 350,000 kilometers square, affecting 14 million people and 16% of Turkey's population, and at least 350,000 buildings were destroyed. Unfortunately, the material and the moral damage and the loss of life, earthquakes have severely affected our country. It is clear that we need to work seriously to to rebuild the earthquake-affected areas, and it is clear that we need to work seriously to rebuild the earthquake zone and to ensure the continuity of our lives. And we made lots of investigations on the earthquake zone, and it showed that approximately 400 million tons of mixed earthquake waste was generated. These mixed earthquake waste include concrete, stones, tiles, bricks, glass, plastic, different kind of the metals, automobile parts. And I can easily say it's not possible to recycle them in bulk, so they should be carefully separated one by one according to their types. By separating these waste, they will be re-evaluated easily in the construction industry and will provide a significant economic and environmental benefits. Although the management of hundreds of millions of tons earthquake waste may seem complicated at first glance, earthquake waste that are carefully organized and expertly managed can rejoin the value chain in our country and in the rest of the world. Here, I just want to show some photos from the deposit areas in the earthquake zone. As you can see here, the problem is huge, and the waste generated after the recent earthquake is currently being deposited in forested areas, pastures, riverbeds, coastal areas, and agricultural lands. Moreover, the potential for reuse of the waste is not being considered when selecting these disposal locations. In recent years, as Hacettepe University, we completed several projects on the scope of the valorization of the different construction and demolition waste products. Today, I would like to shortly mention about the case studies or best environmental practices that we have conducted in recent 10 years. And in this context, one of our projects with real case studies titled Lego Construction System of Green Structural Components for Low-Cost Housing, which had been supported by the UK government and Turkey government. Our ultimate goal in these projects are to develop alternative building materials to Portland cement concrete by geopolymerization of construction and demolition waste, and to develop Lego-type modular demountable structural elements using these concrete. Plus, in addition to these products, we developed two special carbon dioxide capture to the construction and demolition waste permanently, where this carbon dioxide is obtained from the steam gases of different industries, for example, Portland cement industry or steel factories. And according to the results we obtained from the first part of this study, we also carried out a real field demonstration application with the products that we developed throughout the projects. So this is the first phase of the projects. In the first phase, we collected construction and demolition waste separately from different demolition sites and subjected it to crushing and grinding process, just simple crushing and grinding. But the most important thing is to selectively collect the construction and demolition waste. According to initial findings, we realized that the physical and the chemical properties of these wastes may vary from one region to another. We characterized the waste collected from different parts of the Turkey, and we developed different recipes which performs similarly regardless where they are collected. And whatever we found from our initial studies, regardless of their type and origin, different wastes can exhibit similar performance as a result of the proper optimization. In the next step of the projects, we put effort into the development of Lego-type demountable structural elements which have significant time and the cost advantage in terms of the molding, workmanship, structural stability. These elements, which we produced with geopolymer concrete, passed all the structural tests including severe earthquake loadings. At another stage of these projects, we installed a special carbonation reactor in the laboratory for carbon capture of the construction and demolition waste from the steam gases of the cement factory. But it can be easily applied these methods for the steam gas of different industries, for example, steel production or ceramic production or glass production. After the carbonation process, what we found, we have seen significant improvements in the many properties of construction and demolition waste, such as water absorption capacity, compressive strength. It improves the workability of the concrete. In addition, by successful capturing and storing 150 kg carbon dioxide per ton of the construction and demolition waste, we have achieved a significant gain in fight against global warming and the climate change. At the end of these projects, we developed special structural elements and we started to work for the field demonstration activities. The construction and the demolition waste in large tons had been brought to the factory where the structural elements produced, such as columns, beams, slabs, and then with the preparation of the molds and the reinforcement process, structural elements with green concrete. Green means that 100% of the concrete were made by using construction and demolition waste. Here you can see some photos taken during the construction stage, and this structure, as you can see here on the right below, with the size of 400 meters square, is the first modular building in our country entirely constructed with demolition waste, and it has been actively used on the university campus for more than 3 years. In 2020, we have initiated a new projects. In these new projects, we started to work on a smart selective demolition and end-of-life buildings and their circular economy based solutions for various high value added purposes. The short name of these new project is Iceberg. It is supported within the scope of the Horizon 2020. And after this stage, I'm going to provide some information about best environmental practices conducted under this project. I would like to talk about our first application within the scope of Iceberg project as a Turkish case study. Different from our first initial works, in these projects we conducted some studies on the feasibility of producing green wood chip concrete panels using waste wood obtained from demolition area. Waste woods were first collected from the demolition site and brought to the fiber form by crushing and chipping. We conducted special chemical treatments to remove some harmful coatings on the surface of the wood, such as paints. And we enhanced the compatibility of wood fiber between the cementitious material. When we are producing the board, we use these wood chips. Furthermore, in the production of the panels, as you can see from this figure, we used a cement developed from selectively obtained waste bricks from the demolition waste, which we named eco-hybrid cements. Therefore, both the woods and the cement were obtained from the construction demolition waste. And the pilot scale production has been completed by one of our industrial partners. You can see some photos during the industrial production and the quality control process. And what we obtain, the performance of panels are parallel to the panels produced with the raw material. With these projects, our industrial partner has started using waste wood in panels reaching a minimum 30% in their current production process. In this image, you can see one of the type of the village houses decided to be built in the earthquake zone after the earthquake by the Ministry of Environment, Urbanization and the Climate Change of Turkey. With the experience gained from our previous work, we conducted to quickly build the village house with new construction technology by using earthquake waste. In the following slides, you will see some pictures of real scale studies we have carried out under these iceberg projects. Here, in the first stage, we selectively collected concrete rubble from the earthquake debris. In total, we gathered around 1,000 tons of the concrete rubble for all of our activities. The sorted materials, as you can see from this figure, were then transported to the recycling facilities. Concrete waste were crushed and sealed to be used in the production of different structural elements. The brick waste material were also crushed and grinded and then transported to the cement producer to produce additional eco-hybrid cement. And at the end of this process, all materials were transported to the construction site. Here are some structural elements that we have tested on large scale. In addition to the use of construction demolition waste during their production, one of the most interesting and innovative things in these elements is that for the first time, I think, we produce demountable and precast foundation element, not only structural element, foundation also is precast system. And here are some images for all different types of the structural elements such as shear walls, foundations, slabs, and roofs. These products have been developed with demountable technique and will be connected to each other during the construction with the help of the designed connection system as a result of our study. So in order to identify potential problems beforehand and to assess the feasibility of dismantling and relocating the structural elements to another area after installation, in the initial stage, we set up a small demonstration structure on our university campus. These pictures from our department. You can see the installation of images for the structural elements. All elements were brought to the construction site with the help of the crane and placed one by one, starting from the foundation and connected to each other. In the previous slide, as I mentioned, we completed a small-scale single-story house made entirely of the recycled concrete, which can be completely dismantled and reassembled. At this stage, our goal was to dismantle the structure that we have set up at initial stage and send it to the earthquake zone and resemble it there to serve a family affected by the earthquake. In these slides and following slides, I would like to show some of our construction works within the scope of this study, step by step. At this stage, as you can see from this figure, we place the vertical elements and the foundations. In this stage, we completed the placement of the horizontal elements and slabs. Here and in the next slides, you can see the installation of the water, sewage, and the electrical system of the buildings. And upon completing the various items such as roof, door, and window installation, and the electrical and the water system, the building is ready to use. So after our first successful implementation in the earthquake-affected region, our goal is to completely build one village in this manner. And within these AM, different from the first one, we started to construct two-story buildings with modular construction system. Actually, as you can see from the figure, we completed the construction of structural elements for these buildings. The rough construction of two-story modular buildings we completed, and hopefully in the next months, we are going to construct the rest of the fine works for these buildings. I just want to give one final example from our circular case studies. With the experience obtained from our previous works, we have started to work on the development of green concrete incorporating construction and demolition waste to suitable for 3D additive manufacturing. In these new projects, we aim to combine modular construction techniques with 3D additive manufacturing technology. And in this scope, we decided to construct a more architecturally distinctive and technically challenging buildings, as you can see from this figure. And in the next stage, to ensure the construction process without any problem, we decided to divide the structure into fewest possible parts and start the construction process of each part using additive manufacturing, different from our first studies. And after dividing the structure into 11 parts, we proceeded to the printing process. In these slides, I would like to show some pictures depicting the final state of the buildings that we constructed in recent months in Turkey. We spent approximately 30 days from the planning stage to the completion of each part, allowing sufficient time for curing and strengthening before assembling the structure in place. In this structure, we have used the aggregates from the earthquake zone as well. And our next goal after this stage is to reduce the construction time to 1 week with the standardized projects for earthquake-prone areas or low economic level individuals. So at the end of my presentation, I have a question: why circular economy in the built environment is an inevitable necessity for Turkey and for the rest of the world? If we look at, in general, the high level of risky building stock leads to significant increase in urban transformation efforts, resulting in more steel, cement, brick, glass, aggregate, and concrete production, and more construction and demolition waste production. Plus, in addition to the loss of the life and the property caused by the earthquakes or different kind of disaster, the environmental problems also exacerbated to much more serious levels. Emissions resulting from the construction sector are not only affecting our country, but also distributed throughout the world because there is no border on the air. All this, along with the growing population and the internal migration, increases the negative impacts of the country's construction sector on the environment and the natural sources with an unsustainable and non-circular approach in terms of the consumption and production. Therefore, it is vital imperative for both Turkey and the world to create a housing and construction sector where all components of the sector's value chain gain an ecologically, economically, or socially, or culturally sustainable identity and integrate it into the circular economy. With the experiences that we have received in the last years, I think we are ready to recycle disaster waste or construction demolition waste or waste remaining from after the war and integrate into the circular economy by developing green construction materials. So thank you very much for listening my presentation. Now I would like to give the floors to the next speaker of this webinar.
Sorry, I was mute. Good afternoon, everyone. Thank you very much for attending this webinar, and thank you to CircularB for the invitation. My name is Teresa Ross. I'm senior researcher at the Technological Institute of Ceramics in Spain, and it's a pleasure for me to be here to present the tool we are developing and coordinating in the Recordmatic project. This tool is useful to understand, implement, and assess circularity and sustainability of practices and solutions related to the life cycle of demolition and construction waste in all stages of the life cycle of building and constructions. The Recordmatic project aims to develop automated solutions for sustainable and circular construction and demolition waste management. Why? What are the main motivations of running this kind of project? And why this project focuses on construction and demolition waste? Well, there are more than 10 billion of tons of CD. Sorry. There are more than 10 billion tons of CD waste produced in the world. It accounts of between 35 and 65 of landfill occupancy volume. China, USA, and Europe are the largest producers. In Europe, the recovery rate is around 90%. However, its main uses are low value. In addition, Europe has a number of challenges to meet, as the European Green Deal, the European Framework Directive, or Zero Energy and Waste Target. So the aim is to identify the main challenges and to successfully implement the principles of circular economy in CD waste management and outline digital and automated solutions to be developed in the Recordmatic project. The Recordmatic project addresses at least 6 missions that you can see in the screen. The first mission is avoid waste through the integration of secondary materials in design, using a smart design to mitigate future waste generation. Our other mission is to minimize waste, reducing recycled products and byproducts, prioritizing durable materials, employing digital construction planning, or segregate waste on site and reuse. Other is reuse waste, using digital twins in asset management, and continuous structural health monitoring, and force reuse during refurbishment. Other mission is to preserve waste using digital twins in the construction planning and for selective waste selection or dismantle when possible. Sort and treat waste using a smart logistic automated solution for waste sorting and treatment. And finally, valorization the waste, developing basically new products. The Recordmatic, I will be so fast on this, is organized in 8 interacting work packages in parallel over a project of duration for 48 months. Work package 1 is focused on contextualizing automation in construction and demolition waste management, establishing reference values and practices, and developing a digital information management system, which will host the solution developed in the project. Work package 2, 3, 4, and 5 are the technological work packages, and they are focused on digital or automated solutions, covering all the life cycle of construction and demolition waste management. And work package 6, which is the one that we are going to talk about, address the measurements and assessment of the sustainability and circularity potential. it is established to support all technological packages, providing a guidance tool which will be used to evaluate each of the demonstrators, and beyond that, the tool will be able to the market also after the project conclusions. And then the work package of exploitation, dissemination, and coordination, which is organized in work package 7. Here on the screen, you can see the 6 demonstrations that will be run in the Czech Republic, Greece, Spain, Italy, and United Kingdom. All of them are related to automatization or digitalization in the different stages of the CD construction and demolition waste life cycle. And we will now look in detail the tool for understanding, implementing, and assessing the circularity and sustainability of practices and solutions related to construction and demolition waste at the different stages of the life cycle of building, but also in the construction, civil constructions, for instance. This is a guidance tool which is intended to guide non-expert actors in the construction value chain to implement, assess, and prioritize sustainable and circular criteria to prevent, minimize, and mitigate negative impact in the dimensions of circularity and sustainability, and also to identify strength of the solutions and to complement decision-making methods that will be developed in the technical work packages, and this will be done in a quantitative way. Why we are going to develop a tool? Because there are existing methodologies, schemes, and tools to carry out the assessment of some of the dimensions of the sustainability or circularity, like levels, HQE, LEED, BREEAM, but also applied in product, eco-design, eco-labels, design for circularity. But well, we have found that there are few initiatives to put into practice the joint integration of all these concepts together, circularity and sustainability, especially holistic initiatives that are specific for city waste and its entire value network. And also is evident that the complexity of assessment in those dimensions and which require time and expertise. And often this have some limitation when one person or one user wants to evaluate some innovations. So which is the ambition of our Recordmatic tool? Well, it's to facilitate the access for non-experts to understand and to implement circularity and sustainability in their decisions. So there will be an integration of this circularity and sustainability altogether. It will consider of the life cycle. So there is life cycle thinking, is focused on city wastes, but also applicable for all range of fields. It's able to evaluate innovation with few limitations, and is applicable for building and civil construction, and is applicable for new or existing constructions, and integrate all the value chain. To do that, well, Recordmatic team consider that it was very important that the tool to be implemented was aligned with existing methodologies, tools, reference documents, so and also regulations that companies and all the target groups already applied. to them. So a huge of literature review was carried out to identify those methodologies and indicators from many different sources. Even this review has been shared also with CircularB, because we have partners that are in both projects. So at the end, we review 14 sustainable assessment certification schemes in construction, standards related to life cycle assessment and sustainability in building, existing tools and databases for circular economy and sustainability, guidelines for pre-demolition audits, policy regulations, and indicators for circularity, in order to see which to identify the necessities of the target group and the gaps that there were in all the regulation, and how the integration of all of them will form. So after all this review, a preliminary list of 700 indicators were gathered, but we make a rigorous screening process, and we got a final list of 130 indicators grouped in the dimensions that you can see on the screen. And the dimensions were environmental, and the subdimensions, the list that you can see inside each box. And from the environmental dimension, we finally have 51 indicators, the social dimension with all this long list of subdimensions, but with 77 indicators, the economic dimensions with 27 indicators, management and governance, 12 indicators, and finally technical with 17 indicators. Sorry. And now let me explain how is the methodology. Well, it's important. Sorry, I forgot to say that this tool is in progress. We are just in the middle of the project, and we are developing. So we are now working on the validation of those indicators and establishing and defining the methodology. I would like to explain the general methodology of the tool. Well, the tool will be suitable for different target groups. The target groups that we are going to consider are designers, which will be architects, designers, engineers, developers, consultants, contractors, construction companies, but developers, product manufacturers and suppliers, clients, which be users, but also asset managers and waste managers, demolition and construction companies, recycling companies, or decontamination companies. So the tool will be specific for each target group. So the first stage that the user should do when access to the tool is to indicate who are they and where they operate, which stage of the life cycle they have some kind of effect. Then they have to describe or indicate a solution or practice to be evaluated. So the tool then will display a list of applicable indicators, and the user will indicate whether the practice or solution to be evaluated entails any change after the implementation of the practice that is going to evaluate. So the tool will help to measure the indicator and evaluate the changes, thus helping to prioritize strategies to implement circularity and sustainability. When the user, you will see, when the user is not able to define the changes, the tool will provide some guidance to measure. Let's see in detail. once the user describes the process that she's going to evaluate, then the tool will display a list of indicators for each indicators. The tool will ask, well, does it make a difference in any particular aspect? For instance, does it reduce CO2 emissions? And the options that the tool will offer will be, well, this indicator is not applicable, or I don't know, or much worse, same, better, and much better. When the user doesn't know if it makes some difference, the tool will provide some tips to or provide information on how to estimate. If the situation is much worse or same, that is, if the implementation of a measure that within some specific indicator get worse, the previous situation, the tool will give some tips to reflect or improve the situation. If the user can, if we have on this indicator some reference value and the user have some value quantified, the tool will be able to compare those situations and to see how far you are from the objective of being same, at least same or better. If the implementation of the solution is going to improve some specific aspect, that is some specific indicator, the tool will provide information about how to communicate. Again, if we have some reference value and the user has some quantitative value, the tool will compare and will help to communicate to the client, the users, or the rest of the value chain. Moreover, the tool will ask another question. Will ask for each indicator, the user will assess the importance, urgency, and feasibility on implement the question that is addressing. So each indicator, according to their perspective, time, money, urgency, technical feasibility, whatever. By means of an equation, which is under development, the tool will prioritize all the issues to address. So, for instance, if one of the indicators, does it reduce CO2 emissions? If there are no changes, but it's not important, well, then the tool suggests to devote efforts elsewhere. But if there are no changes or there is a little bit of increase, so it's getting worse, the CO2 emissions, and this is very important or middle important, the tool will help to prioritize and will give tips to reduce the CO2 emissions in this case. So this was the methodology, that were the dimensions and indicators that that the tool is going to be addressed. But it was very, very important for us that this tool is applicable, used, and is adapted to the necessity of the target users. So we did some interview, we did some surveys, and now we are running national workshop in all the countries that participate in Recon-Matic project, with the objective to assess the tool methodology and also to validate some specific indicators. And here you have some positive comments that the users are giving us. and some recommendation, constructive recommendation to take into account when we are going to develop the tool. The tool will be programmed and designed online and will be available in some months. So thank you very much. If you need more information, you can visit the webpage or the social media, or just email me and I will be happy to answer. So I think we are going to the next session.
Yes, we are going to the questions and answer session. As we are running late, I propose that we take one question for each of you. Allow me to start with the question for you, Luis. What are the participation schemes in CircularB scientific activities?
Thank you, Catherine. We have several ways of participating. We offer several ways for people participate. First of all, the most important thing is that anybody that is interested in joining our action officially applies, and when he or she officially applies, he or she has to briefly say what is the background, the knowledge, then the motivation to participate in our action, and afterwards what is the expected contribution that he or she wants to give to the action. So this is the basic. Then afterwards we analyze with the core group. We analyze the application. We accept most of them because the people are willing to contribute, and then we invite people to work with us. We have, as already explained, we have working groups, and in each working group we have tasks to develop, and when we start the task, we ask people who is interested in doing this or in doing that, and people volunteer to work, and of course then we organize the work of everybody that is interested in a certain task. So there are other ways of participating. That is the short-term scientific missions. That is an application that the people interested to go to an institution and work during, well, the minimum is 5 days, the maximum is 3 or 4 months, and we can support this this wish of working in another institution, giving some financial support. Of course, if people are only looking to the financial support, this will not work because we do not have much money to distribute. But the few money that we have, we are happy to help the ones that are really interested in contributing to the achievements of our cost action. So I think I briefly explained several ways of participating. Thank you.
Thank you very much for your reply, Luis. As this was a very important question, I raised it first to make sure that that we can start from there. I would like to now go into a bit more of the subject matter with a question to Rand. Could you explain how the circularity indicators will be categorized in the dashboard, and what kind of information the dashboard will include?
Okay, great. Thank you very much, Catherine, for this important question, actually. So as we launched our work on the dashboard, we're starting to work on an Excel sheet. So we did a systematic state-of-the-art to collect all the indicators from existing tools, previous frameworks, frameworks already dedicated only for circularity and others for sustainability. and we are trying to identify the different categories that encompassing circularity aspects and then sustainability. However, like the framework of the tool will be only focusing on circularity aspects because it's going to be later integrated in sustainability broader framework, so just to avoid to replicate the indicators. So we are considering 6 dimensions in our dashboard. We have the technical dimension that is more oriented towards circularity strategies and factors, and then we have also some sustainability dimensions just to be aware of the overlap that may exist in some indicators. Sustainability dimensions, as you all know, encompass the environmental factor, the economic and social dimensions, and then we have the organizational dimension and the cultural dimension. Those are the main 6 dimensions that we are going to be working on. About the information that we are going to include, as I explained previously, we are going to highlight the type of the indicator, whether it's a qualitative indicator or a quantitative indicator, and the way, the method for the calculation of its indicator, and what are the information requirements that we need to prepare or we need to access before applying the indicators. Actually, that called our attention to many barriers in each indicator that also, like, this issue of barriers will be highlighted within our dashboard to highlight this aspect of barriers against the practical implementation of the indicators and try to find later solutions within our framework to overcome these barriers. We will also trying to provide the sources, of course, and validation methods of the indicators to show their practicality and their limitations. So these are mainly the information that we are going to provide. Then we are working on the timeline. Like, we noticed that many indicators and tools were based upon each other. So we started with one tool, like at a later time, somebody or some studies like further develop the same indicator, like with some additional information or resolve some previous issues. So our aim in CircularB not to start from scratch. We are aware of the state of the art and we are building upon it. So I hope that I answered your question with this brief explanation.
I believe so, indeed. I believe so. Many thanks. I have a question now for Mustafa. We received a question, the following: how can material that has been obtained from a structure damaged in an earthquake be recycled and reused into the production of adequate concrete? We cannot hear you, Mustafa. Can you try again to unmute? We seem to struggle with the unmute button today. No, we cannot hear you yet. You might need to click a few times on the button. So did I have to do before? Technical system might fail us. No. Okay, while we are trying to resolve the technical problem with Mustafa, let's maybe already take a question for Teresa. Teresa, when will the final tool be ready, and do you already know what the final format would be?
There will be the first version offline will be this August, but the final online version will be in August of the next year, and also will be validated through the demo case studies that I showed you on screen. So the final validated tool will be in June 2026.
All right, I think we have Mustafa with us again. Shall we give it another try? Go ahead. Now we can hear you loud and clear.
Okay.
Yes.
I actually don't know what is the reason, but just disconnect and connect again. Now it's working. Thanks for your question. Actually, it is good points that we need to consider, because the structure has already collapsed, whether it is good to produce good quality concrete or not. Actually, while recycled concrete aggregates may have slightly different properties compared to raw virgin aggregates, research and technological advancements have shown that they can still be used effectively in concrete production. With right mix design, adjustment, and the quality control procedures, these waste materials can contribute to the production of high quality concrete suitable for various construction applications. Actually, in our applications, we try to use 100%, but we don't need to use up to 100%. This is very challenging. So in summary, utilization of these recycled materials, even from the earthquake damaged structures in concrete production, not only conserves natural resources, but also reduces the landfill waste and energy consumption associated with the traditional construction methods. I think I tried to give the answer to your questions.
Many thanks indeed. As we are coming to the end of this webinar, I would like to extend a very big thank you to today's speaker and to you, our audience, for attending this webinar. And I take the opportunity to remind you that in the coming days, the recording of today's session will be made available on the BuildUp platform and on our YouTube channel, together with the presentation slides. This question was also raised in the chat before. I replied in the chat, but to be sure that everybody has received that message. As this is the first CircularB webinar in a series of 6 with BuildUp, before summer, 2 more CircularB webinars will take place. A first one on, well, the second webinar on Tuesday, the 14th of May, which will zoom in to the CircularB Stakeholder Group policy shapers and regulators. And note the third one down as well on Tuesday, the 18th of May, where we will give the floor to the CircularB Stakeholder Group, investors, developers, and insurance providers. The other 3 webinars will follow after summer. Besides the CircularB webinars, BuildUp has several more webinar sessions in the pipeline, with as the next one on the 7th of May, EU Peers Project and OpenGela project. Keep an eye on the BuildUp calendar of events and our social media for updates on more webinars. Then be sure to register on the BuildUp website to be able to share and disseminate your own content, and follow us on social media for updates. Finally, please remember to complete the BuildUp survey. We have shared the link to the survey in the chat so that we can make sure your voice is heard, and please do so by the 31st of May. We wish you all a very pleasant end to the week. Thank you and goodbye.
Thank you. Goodbye. It was a pleasure.
Many thanks. Bye.
Bye.